Hello everyone, I'm Edgar. Today I'm presenting a network modernization proposal using SDN and SD-WAN. The main goal is to reduce rising WAN costs, improve performance during peak usage, and make the network easier to manage as the company continues to scale. With that being said, let's move on to today's agenda. In this briefing, I'll start with the current network state and the biggest pain points. Then I'll explain SDN and SD-WAN in plain terminology. I'll walk through the future state architecture that we plan to implement in this organization and give vendor recommendations as well. I'll also cover a phased roadmap with risk mitigation, and I'll close with leadership and innovation. Let's start with the current environment that your organization currently has implemented. Right now, the organization relies on traditional networking hardware across multiple branch locations. Connectivity is built from a mix of broadband options such as fiber and cable, plus LTE and traditional MPLS links. One important detail is that traffic often gets routed through headquarters or data centers first, even when users are trying to reach cloud or SaaS applications, such as Microsoft 365. This design creates high latency. It adds congestion during peak hours and increases overall operational costs. That leads directly into the business pain points. The organization growth is now exposing the weaknesses of the traditional model. Costs continue rising, especially due to MPLS and complexity of supporting multiple WAN providers. Performance drops during high traffic period, especially for cloud-based workloads. Operationally, even new branches add more manual configuration, more troubleshooting, and more inconsistency. And even visibility is limited. It takes longer to detect issues, isolate problems, and restore services. Now let's talk about the solution SDN and SD-WAN has to offer. So what are these new form of network architecture? SDN and SD-WAN help improve these challenges by shifting network control from individual hardware configuration into a centralized software policy. SDN, or software defined networking, means we manage and automate networks behavior centrally. Policy and segmentation becomes consistent, and changes can be made faster with fewer manual touchpoints. SD-WAN, software defined wide area networking, takes the same idea and applies it to the wide area network. Instead of a single fixed WAN path, SDN WAN intelligently uses multiple transport links and routes traffic based on what the application needs and how the network is performing in real time. SDN simplifies control and policy. SD-WAN improves performance and resiliency across branch connectivity. Here's the target architecture that we want to bring to life. The slide is the center of the proposal, our recommended future architecture. At each branch, we deploy SD-WAN edge devices. Think of these as smart WAN gateways. It connects the site to multiple WAN transports and enforces policy right at the branch when the users and traffic originate. Each branch can use multiple WAN connections such as broadband for cost-effective bandwidth, LTE, 5G for backup and continuity, optional MPLS during transition or for specific requirements. What makes this powerful is that SD-WAN can use these links intelligently. It can route traffic actively across multiple paths, and it can fail over automatically if performance drops. In the middle is the SD-WAN fabric. This is the overlay network. Software built secure tunnels on top of the underlying ISP links. It handles encrypted connectivity and intelligent intelligent routing decisions. The orchestrator is the control layer. This is where IT defines rule once, like which apps gets priority, how segmentation works, and what failover behavior looks like. It then pushes those policies across every single site. Finally, the design supports three major destinations: HQ and data center workloads, public cloud workloads, SaaS applications such as Microsoft 365. This is a major improvement over traditional WAN routing, where traffic often gets forced through HQ first. Here, traffic can be routed securely and efficiently to the destination that makes the most sense. Now let's connect the architecture to the outcomes the business will feel. SDN and SD-WAN solve the biggest issues in three major ways. First, they reduce costs by shifting more traffic broadband while keeping MPLS only where it's truly needed. Second, they improve performance through application-aware routing and real-time path selection. Third, they increase resiliency by enabling multi-link failover and improving uptime across branch sites. Now I'll recommend technologies and vendor options um, that have the capability to provide this new architecture. For technology and vendor strategy, I recommend selecting an enterprise SD-WAN platform paired with centralized data center policy enforcement. My primary recommendation for this organization is the Cisco SD-WAN, also known as Veptilia, combined with the Cisco ACL. This provides enterprise proven scale centralized orchestration, strong segmentation, and long-term vendor support, while keeping the design aligned with future growth. For flexibility, there's also another strong option like VMware, Velo Cloud, Fortinet Secure SD-WAN, Palo Alto, Prisma SD-WAN, and Aruba Edge Connect. And if the organization needs a more open source route, an option like FlexiWAN and SDN controllers such as Open Daylight or ONOS may be considered as well. But that requires stronger internal engineering resources to manage at scale. Here's the business case and what success looks like. The business can come down to measurable improvements. This modernization reduces WAN spend, it improves users' resilience, and makes the network easier to operate and scale overall. We also gain faster branch deployment through centralized templates, stronger security with segmentation, and improved visibility into performance and troubleshooting. The end result is a network that supports productivity today and growth in the future. Now let's talk about the rollout and risk management. This rollout should be phased to reduce business risk. Phase 0 is discovery and design. We inventory applications, classify traffic, and define policies. This leads to phase 1, which is the pilot. We deploy SD-WAN into small groups and sites and validate performance and reliability. Phase 2 is scale out in waves. Region by region, deployments using standardized templates that were created during phase 1. Phase 3 is optimization. We tune performance, expand automation, and evaluate SASE integration if needed. Key risks include downtime, change resistance, and resource constraints, which mitigate those through stage cutovers with rollback plans, structured training, and a phased rollout that avoids overwhelming IT operations. Now I'll close with leadership innovation and the bigger picture. The solution isn't only about fixing the network. It's about enabling innovation. SDN and SD-WAN create a cloud-ready foundation that supports modern digital transformation and future growth. Automation reduces manual work, errors, And centralized control improves governance. The network becomes more adaptable as the business needs change. From a network, from a leadership standpoint, success depends on clear alignment across IT, security, and operations. Removing blockers early and tracking outcomes like costs, savings, uptime, application, and performance. To finish, here are the recommended next steps. To move forward, the next steps are clear. First, approve a pilot budget and vendor evaluation. Second, assign executive sponsors and project lead. Third, define success metrics like cost reduction, performance improvements, uptime, and security compliance. Once the pilot proves the value, we roll out in phases and optimize continuously. Thank you for your time, and at this point, I'm happy to take any questions.